You ever have one of those hunches, a nagging question or a problem that you just can't seem to shake? We all do, but how do you go from that vague feeling to an answer you can actually trust? Well, today we're going to unpack the structured quest we call research, not as some boring, stuffy academic thing, but as a genuine adventure to find knowledge you can really count on.
Right, let's just start here, because this is the big one, isn't it? I mean, we are drowning in information, opinions, and hot takes. So finding answers we can actually trust is a superpower. And this isn't just for scientists and lab coats. It's for anyone who has to make a smart decision. So the tool for this quest, it's called research. And this definition here tells us something really important. Research isn't just about randomly collecting facts. It is a systematic inquiry, a methodical, organized process. The whole point is to describe, explain, predict, and maybe even control what we're seeing. It's basically the most reliable map we have for navigating the unknown. Every great adventure story starts with a call to action, right? For a researcher, that call is a problem. It's that moment you look at something and think, that's not right, or this could be way better, or just, why does that happen? And here's the heart of it. A research problem is basically a gap between where we are right now, the actual state, and where we want to be, that desired ideal state. Research is all about building a bridge across that gap. But, and this is a huge but, you have to make sure you're solving the real problem. It is so easy to get distracted by the symptoms. Think about it. High staff turnover? That's a symptom. The real, deep-down problem might be something like low commitment among your younger workers. If you just focus on the symptom, it's like taking a painkiller for a broken arm. It might feel better for a minute, but you haven't fixed a thing. So, a real research problem isn't just complaining. It's a specific condition that needs to get better, a roadblock that needs to be removed, or a question that's so bugging you it demands a serious, focused investigation. That's the difference between just being curious and being on a real mission. Okay, so once you have your problem, you gotta sharpen it. You turn it into a research question. This is where you go from a broad issue like low commitment to a super specific, answerable question that's going to be the North Star for your entire journey. All right, you've got your question. Now it's time to plan the expedition. Look, a smart explorer doesn't just stumble into the jungle, right? No. They study the maps, they learn the terrain, they figure out what's already known before they even take their first step. In research, we call this map making, the literature review. You're basically diving deep into what other explorers have already found. And the goal isn't just to see what they did. The real goal is to find the edges of the map, the spots where knowledge ends. That's where your adventure begins. Now, this is cool. Every research plan is built on some core beliefs. Think of it as answering 3 huge questions. First, what is reality? Like, is there one single objective truth we can measure, or are there lots of subjective truths based on people's experiences? That's ontology. Second, how do we even know things? Through numbers and hard data, or through stories and interpretations? That's epistemology. And once you answer those 2, you can pick your tools. That's your methodology. These choices determine everything, whether you're going to use a survey or an interview, an experiment, or a case study. And the path you choose usually falls into one of 2 buckets. Basic research is all about knowledge for the sake of knowledge, just expanding the map. It's theoretical. Applied research, on the other hand, is about finding a practical solution to a real-world problem, like right now. Either way, once you've planned your path, it's time to get your boots on the ground. The map is drawn. The plan is set. This is where the real action begins. It's time for the expedition itself. Getting out there in the world and actually gathering the clues, the raw data, the evidence. So first, you have to identify your population. And this doesn't just mean people. It's the entire group you want to say something about. It could be all the small businesses in a city, all college freshmen in the country, or even every customer complaint from the last year. It's the whole universe you're studying. But let's be real. You can't talk to every single person or analyze every single item in a population. It's just impossible. So what do? You select a sample, a smaller, manageable group that represents the whole. You study the sample to understand the population. Now here's the super important part. How you pick that sample is everything. Probability sampling is the gold standard. Think of it like a lottery, where every single person in the population has a fair shot at being chosen. That randomness is what gives you the confidence to say what you found in your sample is probably true for the whole group. Non-probability methods are often way easier and faster, but there's a catch. You might get a biased sample that doesn't really reflect the bigger picture. So what's in your toolkit for this expedition? Well, you've got a lot of options. You could use questionnaires to get info from tons of people at once. You could sit down for deep one-on-one interviews to hear someone's story, or you could just be a fly on the wall and observe what's happening. Each tool is designed to gather a different kind of clue. Okay, you're back from the field. You've got notebooks full of interviews, a pile of survey responses. You're loaded with clues. Now for the most exciting part, cracking the code and finding the hidden story in all that data. To do that, we need to talk about variables. First up is the independent variable, or IV. Think of this as the cause. It's the thing you, the researcher, change or control to see what happens. And the thing you measure to see if there was a change? That's the dependent variable, or DV. It's the effect. Its value depends on what happened with the independent variable. Finding the connection between these two is the name of the game. Let's make this real. Does the number of hours you spend studying, the cause, actually change your test score, the effect? Does the amount of time you spend on social media affect your self-esteem? This cause and effect relationship is what researchers are trying to figure out. So how do you analyze the numbers? You've got two main lenses. Descriptive statistics are pretty straightforward. They just summarize the data you have. What's the average? What's the most common answer? That kind of thing. But inferential statistics, that's where the magic happens. You use powerful tools to analyze your small sample and then make an educated guess, an inference about the entire population. That's how a drug trial with 1,000 people can tell us if a medicine will work for millions. The code is cracked. You've answered your question. But the journey is not over. The final, and you could argue the most important step, is to share the treasure. You have to bring that new knowledge back to the world so that everybody can benefit from it. And you do that with a research report. But don't think of it as just some dry document. A good research report is a treasure map for all the explorers who come after you. It shows them exactly where you went, how you got there, and what you found, so they can check your work and, even better, build on it. So there it is, the journey from a simple question to a powerful conclusion. It's not some random walk in the dark. It's a structured, repeatable process that anybody can learn. The path is clear, which really just leaves one question. What problem out there is waiting for you to solve? What question will you start with?